In the paper entitled Application of Hierarchical and Distributed Cognitive Architecture Management for the Smart Grid, a new architecture is proposed for the management of the smart power grid. Firstly, the transformation of the electricity grid into a smart grid will enable the management of decentralized intermittent production of photovoltaic panels and wind farms, and will increase the reliability of the grid by making possible the joint management of electricity production and consumption. This transformation requires installing intelligent devices throughout the grid and deploying a dedicated communication network for the coordinated management of the entire grid. Because of the throughput limitation of power line communication and of the price of the establishment of a wired network, we think that wireless communication can be used for some of the smart grid communication. Unfortunately, nearly all the usable spectrum is already reserved for various applications, such as mobile communication, Wi-Fi, or television. The licensed users or primary users who reserve the band are not always active. Consequently, a band reserved for a service is not always used. With cognitive radio, a secondary user can use the spectrum reserved but unused by primary user, and a new communication network can be inserted in an already reserved band. Thus, cognitive radio can be used for smart grid communication. HDCRAM means Hierarchical and Distributed Cognitive Radio Architecture Management and is the logical architecture used for the management of cognitive systems. This three-level architecture was first proposed for the management of cognitive radio equipment, but can be used for the management of any intelligent system, such as the smart grid. With this architecture, each element or operator of the cognitive system is linked with the level 3 unit, which can quickly make local decisions. A level 2 unit can use cognitive information collected by level 3 units to make decisions involving several operators. Finally, the level 1 unit is used to make global decisions which can involve the whole system. Moreover, this architecture is composed by two independent paths, one for cognitive information and the other for reconfiguration orders. To map HDCRAM on the smart grid, we first have to identify the operator of the intelligent system managed. If first suppose a home with several devices which can either store, produce or consume electricity, each of these devices can be linked with a level 3 unit. And all those level 3 are connected to the level 2 of the house, which is the home smart meter. The smart meter can make decisions for the coordinated management of all the devices in the house. The level 2 is connected to the level 1 unit, which manages the whole distribution part of the grid and which is linked to the market. For implementation, we only consider the home management, i.e. the level 2 and level 3 of the management architecture. The house considered has certain devices which can either produce, store or consume electricity. And the aim of the home smart meter is to minimize the amount of electricity exchanged with the grid. To highlight the interest of the proposed management, we compare the total power consumption of the house with and without smart meter. The total power consumption for 1 hour is equal to the amount of electricity taken or given to the grid, and its expression is the sum of the electricity consumed by devices less the electricity produced by the photovoltaic panels, plus the electricity delivered by the batteries, which can be positive or negative. With the proposed management, the peak consumption is reduced from 5,000 to 900 watts, and the amount of energy exchanged with the distribution grid during the day is reduced from 69,000 to 4,500 watt-hour. Thus, the smart meter allows to reduce the pressure on the grid, and so the number of failures is reduced, and the management of the grid at level 1 is facilitated. Thanks for watching.